In this video, we will learn 3 rules that will come in handy when solving questions on arithmetic operators. Firstly, a good way to remember data types is as per size, as shown on the screen. Try to remember this sequence. It will help you to master the rules that we'll discuss now. Let's begin with Rule 1. If an operation is performed between small data type and large data type, the result is of large data type. For instance, when an operation is performed between int and double, the resulting value will be of type double. Double occupies more memory than int. So, in this case, int is smaller data type and double is larger. 10 is int and 4.2 is double. When we add them, the result is 14.2, which is double. Fairly simple rule, right? Let's check the next one. Look at the sequence of data types in the blue table. Rule 2 says, if an operation is performed on data type smaller than int, that data will be treated as int. This applies to data types smaller than int, which are char, byte, short. Consider an operation between byte and float. How would you solve it? First, check Rule 2. As per Rule 2, byte data type will be treated as int. Float with byte thus becomes float with int. How do we solve it now? Apply Rule 1. As per Rule 1, int is smaller data type and float is bigger. Int with float will thus give float. So that's how we were able to quickly solve an operation between float and byte using these 2 rules. Let's take another example, an operation between byte and byte. So, as per Rule 2, this will be treated as an operation between int with int, because all data types smaller than int are by default treated as int. In the same way, if an arithmetic operation is done between char and char, it will be treated as an operation between int and int. Let's test your understanding on this. What happens here? Look at SOPLN line. CH is char, and we know 1 is an integer, meaning int. This is an example of an operation between char and int. As per Rule 2, char will be treated as int. How? Using its ASCII code. ASCII of capital A is 65. Char with int becomes int with int. So we have 65 and 1. Thus, SOPLN CH plus 1 is SOPLN 65 plus 1. The output is 66. That's how, using these rules, you can quickly solve problems. Can you guess the output here? Line 2 is example of operation between byte and byte. As per Rule 2, this will be treated as int with int. And then, as per Rule 1, int with int gives int. The result of a plus 5 is thus of type int. Int takes 4 bytes and we are trying to store this in B. But B is byte data type and can only hold 1 byte. Can we store 4 bytes of data in storage of 1 byte? No. Hence, the answer is compilation fails. How to get rid of the error? Very simple. All we have to do is change data type of B from byte to a data type that can hold 4 bytes. So, change B from byte to int. How about this question? Does this work? This is similar to the last question. Line 2 is an example of operation between char and int. As per Rule 2, this will be treated as int with int. And then, as per Rule 1, int with int gives int. Int takes 4 bytes and we are trying to store this in variable B. But B is char data type and can only hold 2 bytes. If we try to store 4 bytes and 2 bytes, compilation fails. Hence, answer is compilation fails. Next. How about this? On line 2, the operation is between int and int. As per Rule 1, int with int gives int. The result will be of type int. Here's the twist. Even though 20 by 40 is 0.5, we know the result will be of type int. So the fractional part from 0.5 is omitted, and int part is stored in variable c. Thus the output is integer 0. What if C was made double? Would the output change? That's the next question. Let's find out. On line 2, operation is between int and int. As per rule 1, int with int gives int. 20 by 40 thus gives 0. But as you can see, we are trying to store the output in double variable. 0 is an integer. To store it in double, it is converted to floating number by appending 0.0. Thus, 0 is stored in variable C as 0.0. And output is 0.0, not plain 0. Next. Would you be able to guess now? We made B of type double, and we're printing A divided by B. In this example, the operation is between int and double. According to rule 1, result of int with double is the larger data type. The output is thus of type double. The answer is thus 0.5, which is double, and that's the output. So these were some tricky questions, and we saw how using these rules, we can find answers to them. Let's move on to Rule 3. Rule 3 is simple. All it says is, the table we used along with Rule 1 and 2 are not applicable for compound operators and increment-decrement operators. Let's test this out. What would happen on line 2? Line 2 has compound operator plus equal to. Hence, Rule 1 and 2 are not applicable here. B plus equal to A means add B plus A and store the result in B. Hence, final value stored in B is 5 plus 10 equals 15. Easy, right? However, if we change B plus equal to A and make it B equals B plus A, then code will not compile because Rule 1 and 2 will be applied. Okay, last question of this lecture. Does this work? Line 2 has increment operator plus plus. Hence, Rule 1 and 2 are not applicable here. Char will be treated as char only and not int. A++ means move the next character after A. It thus changes value of variable from A to B, and thus output is B. However, if we change above code A++ to A equals A plus 1, then code will not compile because Rule 1 and 2 will be applied. A plus 1 will thus give int, and you can't store int in char storage. So, these were some very tricky questions, and we've seen how to go about them using these easy-to-remember rules. That's it for this video. You've learned tons of new information, and I have more lined up in the next video. See you there.